Back in primary school, do you remember having these things? I'll give you a look. Hopefully you might see that there. Remember these things? They were used to help you count sort of ones, tens, hundreds, that sort of thing. Well, I'm going to tell you how you can use these to help you with Pythagoras Theorem. Okay, so imagine that we've got those primary school blocks here. We've got a 3 by 3, we've got a 4 by 4 there. So essentially imagine that's 3 centimeters by 3 centimeters, this is 4 centimeters by 4 centimeters. So what I need to do is need to find another block set that would be able to fit diagonally to make a right angle triangle. Why do I want to make a right angle triangle? Because this corner here will make a right angle. So here we go. The moral of the story here is when you're filming explanations, don't use pink marker. Anyway, back to the story at hand. I've got a 3 by 3 block and a 4 by 4 block and a 5 by 5 block. So essentially, I was able to get these sorts of blocks, all able to make a perfectly equal triangle. Assume that my attempt at ruling lines on a whiteboard is perfectly straight. So in other words, if I was to mark them as 3 centimeters by 3 centimeters, and that this was 4 centimeters by 4 centimeters. This is 5 centimeters by 5 centimeters. Then what we've got here is a very interesting relationship. How many squares are there in here? Well, there's 9 squares there. How many squares have I got here? 1, 2, 3, 4, 4, 8, 12, 16 squares there. And how many squares are here? 1, 2, 3, 4, 5, 10, 15, 20, 25. Or otherwise 5 by 5, 4 by 4, 3 by 3. Now, this is even more interesting. Well, at least I think so, because mathematics is very interesting. If I was to add these together, so 9 plus 16, what does that equal? Well, 9 plus 16 is 25. Boom! That's this number here. So in other words, if I was to have this area here plus that area there, it's equal to this area as well. So when Pythagoras, when he wasn't afraid of beans or whatever else, came up with this formula, which was c squared equals a squared plus b squared, then what he had was, think of this as c squared, that area is c squared, this is b squared, that area, and this is a squared, this area. Okay? So that's where he came up with those particular, had those sorts of squares, and that's where that comes from. That's why we've got this formula. Now what we're going to do is also show how to rearrange that formula. So what if there's some other things that we know as well based on this? A bit of an erase here. So let's erase that. So, also we know, let's just say, we know that 9 plus 16 is 25. Well, also, what's 25 take away 16? Okay, 25 take away 16. Well, that's going to be 5 take away 6 you can't do, borrow 1. 15 take away 6 would be 9. In other words, it's equal to this. In other words, c squared take away b squared is equal to a squared. See? This area here, take away that area there, is equal to this one. And similarly, if I was to do this, what would be 25 take away 9? 25 take away 9 would be 16. This square. So in other words, c squared take away a squared is equal to b squared. So when you were looking at those formulas and going, but what, why c squared, why take away that and so on? This is why. And hopefully this makes Pythagoras just a little bit more easy to understand.